Hello and welcome to another video tutorial on how to use Matlab. Today I'm going to show you how to use the plot function. And to do this, I'm going to change the directory to my desktop and create a new M file by right-clicking into the current directory and clicking New M file. I'm going to name this demo plot. So open it. We don't need this one right here. Instead, I'm writing clear all, close all, and CLC to delete my current workspace, to close all windows, and to empty my command window. So first we need an input. So I want to plot the sine function, and to do that I'm going to define a vector x from 0 with a step size of 0.1 until 2 pi and enter semicolon, so there's no output. Then I need a second vector with the sine values of my first vector. So I'm typing sine of x semicolon, and then I can plot this by using the plot command and entering the two vectors. Now you can press F5 to run the M file, and the figure will open up with the plot of our sine function from 0 to 2 pi. You can also change the design of the plot by making it, for example, red with stars or any other design. If we now want to add a cosine function into our plot, we have to create another vector. So I'm going to name this first one y1 and the second one y2, cosine of x, and also entering another plot command where you have to pay attention that you also plot the second vector, maybe in a different color, so I'm choosing blue. Save this. You can now press F5 to run it. Okay, here's another error because I wrote a capital X. But if you run this now, you see that only the cosine function has been plotted. And this is because Matlab first plots the first curve and then overrides it by the second one. So you only see the second one. To fix this, we have to add a keyword named figure and also hold on, which means that both plots should be in the same figure. If you run this now, both curves are in the same figure. Now we want to set a title for the figures by using the command title and setting the title in between apostrophes. So I'm naming the figure sine and cosine. And to set labels for our x's, we can type x label and also y label. And if we run this again now, we can see our title and our x label and our y label. To set a legend, we can type legend. And because we have two plots, we can also assign two entries for our legend. So I'm gonna name the first one sine and the second one cosine. And run again to see that our legend appears inside of the plot with sine and cosine. I want to show you another possibility on how to plot our two curves. This is done by using a subplot. Subplot will also plot it in one window, but the difference is that we have a split view. So because we want two subplots, I'm setting here a 2, and the first one should be our sine function and the second one our cosine function. So like this. And if we run this now, you will see that we have two subplots inside of one window with a sine and cosine function. We could also add, of course, a title, labels for the axis or a legend, but we don't want this now. So this was on how to plot in 2D. I now want to show you how to plot in 3D. And for this, imagine we have a measuring instrument at a certain position. Let's say x1 and y1, and the instrument is set up in a height of 1.60 meters. And we have a reflector, I'm gonna name it ref1, which is at a position of, let's say, x10, y5, and in 2-meter height. And to make it more realistic, let's imagine we have measured the reflector 15 times. So we need to add a random vector of 15 rows. And to make it more reasonable, I'm also going to multiply it with 0.1, so our values of our random matrix get a little smaller. And this is of course also done for our x and z values, so also multiplied by a random vector. And to set a second reflector, I'm gonna name it ref2, which is at a slightly different position, so x5, y8, and z4. To plot this, we again use the command figure. And to set it as a 3D plot, we type plot3, so Matlab knows we want to make a 3D plot. And similar to the ones in the 2D version, we of course also want to plot our x, y, and z values. First, the ones of our measuring instruments, so I'm typing S1, S2, and S3. Let's say with red stars, so R star. Now for the reflectors, we also use plot3 and then the coordinates, so ref1 1, ref1 2, and ref1 3. This one in green maybe with dots. And of course the second reflector, just the same as the first reflector, but this in black. Now we would face the same problem because we have again 3 plots in a row, so we have to add the command hold on. And then we can save it and run. And then we see here our resulting plot, which we can rotate using this button. And we see here our reflector number 2 in black. And we can zoom in a little. But to show not only a single point in our plot, we have to change our input, because right now we are just typing in ref1 or 1, which refers to the first value in our vector, but as we want to show every single point in our vector, we have to add a colon here. Because if we look into our workspace, we see that our matrix has lots of values in each column, and since we want to plot every column of it, we have to add the colon inside. So we'll add this everywhere. Plot every row of column 1, 2, and 3. Also for our reflector number 2. And if we run this again, then we can see that our station is marked here, and our 2 reflectors above here. So we have reflector number 1 in green and reflector number 2 in black. And if we rotate it or zoom in, we can see that we have a little cluster of points. To improve the design, we can now, of course, again add a legend. So I'm typing here our own position and then the position of reflector 1 and reflector number 2. Then again, to set a title, we enter title and in brackets the name of the figure, which in this point would be surveying arrangement. And finally, we set our labels for the axis. So again, X label, X. And because we are in 3 dimensions, we of course also now have a Z label. So not only Y, but also Z. And if we save this and run again, then we can look at the result. Here it is. So if we turn this a little, you can see how it looks like. To set a grid inside our plot, we can just enter a grid on. So if we now run it, you can see that our plot has a grid, so it looks a little more 3-dimensional. And if we turn this here, you can see down left our azimuth and elevation angle. And for this view, we just keep in mind 30-30. And if we want to open our plot just in this angle, we add view, and then in round and squared brackets we enter 30-30. So then if we run this again, we can see the plot at first sight in this angle. And if you need this plot for your assignment or anything, you can use the save as command. So we type in save as, and then we need the object key for our current graph. So we just type in GCF for get current figure. And then we add the name of our figure. So in this case, surveying arrangement .png. And if we save this and run again, well, if we look at the current directory, then we see that first we have our figure here, but also Matlab created a PNG of our figure. So if we open this, it looks like a normal graph you can then use for your assignments or whatever. So that should be it for today, and I hope you got an impression on how to plot with Matlab. So see you next time.